Number 7, theorem 1.5, and we're stating that we have a, b equals 0 if and only if a equals 0 or b equals 0 or both. So if and only if means a is 0, then 0 times b equals 0, or b equals 0, then a times 0 equals 0, or both 0 times 0 equals 0. And it also says that it's going back the other way. If we have 0, then a has to be 0 or b has to be 0 or both. So it's going both ways. So that's what we mean by if and only if. It works both ways. So proof, suppose that a times b equals 0. And we're also saying in our proof either a equals 0 or a does not equal 0. Well, if a does not equal 0, then b must equal 0. So, all right, let's get started. So here we have ab equals 0. Well, we said here if a equals 0, right, then that would make this 0 times b equals 0. And so 0 equals 0. So a equals 0. If a equals 0, then ab equals 0 holds. Okay, so now let's look at if a does not equal 0, then b must equal 0. It doesn't, the theorem doesn't get into, doesn't state if a equals 0 or a does not equal 0. It doesn't state that b equals 0, but if a does not equal 0, then b must equal 0 for ab to equal 0. So we're saying here that we want to let b equals 0. And we're saying that a does not equal 0, so we want an a, b in there. So if we said b times 1 is going to be the same as b, and that's just the unit for multiplication. And we also know that a times its reciprocal we apply the commutative property AB times reciprocal of A. Well, we said that AB equals 0. So A times B is 0. So we multiply the reciprocal to that. And 0 times the reciprocal of A. Since A does not equal 0, then it can be some other number. Well, 0 times that is still 0, so therefore when A does not equal 0, B does equal 0, and it holds. And that's all there is to this video.